Hello there, Year 12 VCE students. I've brought memes this time and I'm lock and loaded, ready to go. I've actually gone through already and already put the solutions to the questions. I'll just be explaining them with further voiceover detail as we go along. And I'll put calculator solutions to the questions that need a calculator to solve them, but surprisingly only 8 out of the 20 questions, so less than 50%, you should actually use a calculator in to solve, and then maybe like 4 other questions, like the calculator helps, but it doesn't really do anything. So only 8 of the 20 questions you should actually be using a calculator in for this multiple choice section. And I'd say the multiple choice section is generally harder than, can be harder than the external response section. And I definitely think you should have more of your exam book dedicated to the multiple choice section than the external response section. Also, I think this resource here, this video I'm making, is probably the best resource you'll find. The only other 2 resources on the multiple choice section of 2020 VCE exam is iTutor and VGAR, and both of those suck because they're 2 to 3 lines of working out. So this one, delivered to you by McLovin, will, I suspect, be much better, and I'll literally go through it in as much detail as possible, so like you can't leave anything out. So without further ado, let's get into it. So the first question here is quite a simple question, as long as you know what you're looking for. So first, they want, so everything's in terms of the function f and the function g, and they want g in terms of f of -1. You know, f of -1 is already equal to 4. That's the first thing they tell you. So you're basically asking for g of 4. G of 4 is 6. Question 2. This is a classic remainder theorem question. If you don't know the remainder theorem, it's too complicated to do a proof for why it works in here. It'll take too long. So if you want a proof of why it works, then you can look that up. But otherwise, you just need to know that the remainder theorem is just p of x over the expression it's being divided by, which is here it's x plus 2. The remainder is going to be equal to that function here, p, and then you plug in the negative of whatever's attributed to the x. Sorry, like you treat it like as in, so like you had x plus 2, you have the expression equal to 0 on the bottom, and then you solve for what x is going to equal to, and then whatever x is equal to, you put into here. So say it was 2x squared plus 9 as what it was being divided by, then the x value would be, you know, something like that. And you'd sub that in for p. You do p of whatever that is. But for this one, you do x plus 2 equals 0. You get x equals -2, so you do p of -2. And then by hand, you can do it by hand or by calculator, both work. So this gives you the remainder, p of -2. We already know the remainder is equal to 5. They tell you that's 5. So you set whatever you get for p -2 equal to 5. Solve for a. Very easy by hand. Calculator, just store it, solve it. Easy. A equals -2. Question 3. We have f dash of x. That means the derivative of f of x. Okay. So we want to integrate this in our calculator. And when we integrate in the calculator, we're just going to get this. Now remember, when you integrate, there's always going to be a plus c, especially because we're integrating it without, we're doing indefinite integration, so it's always going to be plus c. And then, so we store this with the plus c as f of x in your calculator, and then after that, you've add the plus c, you solve f of 6 equals 4. In terms of c, you get c equals -2, and then that's your answer. With this question, it's a very heavy calculator question. You literally just chuck it into the calculator. And once you've chucked it into the calculator and you solve it for what x is equal to, then you get these 2 things here, right? This one is just here. All of these ones have a denominator of 6. So all you have to do is change the 2 into a 6 and then multiply top by 3 and you end up getting D. Pretty simple question. It's just in your calculator you get n instead of k, so you realize that n is equal to k. and a bit of intuition. Very easy question though. All right, question 5. Okay, so question 5, we have f of x, and then, so we want to expand this, right? Whenever we're finding the asymptotes, and you have an improper fraction, so like we have a lot on the top, they want to expand it, and I believe it's menu 3 for the t inspire. So you get expand up, you do expand in terms of x, and then you end up with something like this. And then here's what you do using logic. So the way you find the y asymptote is you set as x approaches infinity, right? As x approaches infinity, you get this divided by an infinitely large number. So anything divided by an infinitely large number, it becomes 0. So this is eliminated, and you get f of x approaches -3, basically, as x approaches infinity. So that's what the y asymptote is, -3. Or you just think about it as that gets cancelled and you get -3. And then the x asymptote, everyone knows, you set, so the denominator equals 0, so x minus 5 equals 0. And then you get x equals 5. Because when the denominator is 0, fx undefined. With your calculator, there's a cool feature where you can solve your function is equal to 1 divided by 0, or any number divided by 0 in terms of x, because then your calculator will basically solve. That's basically like saying to your calculator, please solve for me when f of x is undefined, and it'll give you x equals 5. But that doesn't have a very wide use case. I just do logic by hand, much easier. Question 6, all right, this is a good question for your exam book. So we have derivative graph here, so it's like showing the slope at different x values. So for different x values, it's saying what is the slope, what is the derivative. And the derivative here is equal to 0, because this is 0. So we get a derivative equals 0, and we know when the derivative equals 0, that's a turning point on the normal f of x graph. So at these x coordinates, like let's say -1, -3, we have turning points. And then for graph B, that's what that looks like. At roughly those x values, we get turning points on the graph of f of x, which is what we want. So it's B. For question 7, you just have to recognize you have e. We're trying to differentiate something in terms of e to the power of, so the e stays the same, and the power stays the same, but you bring the derivative out the front. But we're finding the derivative of g of x squared. G is a function, a differentiable function, and x squared is a function, okay? So we have to apply the chain rule here. So first we find the derivative of the outside function, and the inside function remains the same. And then you multiply everything by the derivative of the inside function. Okay, so then I get this as an answer, which is C. All right, for question 8, we have 25 boxes, so n equals 25. Your sample space is 25. The mean number of defective box items in a box is 1.4. So your mean is 1.4. Since an item can either be defective or it's not defective, it is a binomial question. And it's asking for more than 3. So it's CDF, or cumulative distributive function. So we know pretty much everything except for the probability. What is the probability that's defective? That's P. And we need that for the binomial CDF. So we have to use this formula. The mean, or the expected value, is equal to the sample space times the probability. So then we just work everything around. We get P equals 7 over 125. And then we just chuck everything into binomial CDF on the calculator, with 4 as your lower limit because it's more than 4, and 25 is your upper limit because 25 is your sample space. You only have 25 boxes. And you should get spat out an answer of 0.048. Okay, question 9. Okay, this question is hard to know what to do with it. If you know what to do with it, it's pretty simple. Okay, so the first thing we know is we have a function, okay, f of x. When integrated in the interval 4 to 8, you get an area of 5. That's the area under that graph from the interval 4 to 8. Okay, in this new interval, which has happened because it's being transformed, okay, so it's the same graph, but it's a new interval, so it's being transformed. We have two transformations happen to it. We have this transformation and this transformation. Okay, now you should know that this is a transformation of 2 in the negative x direction, and this is half, a dilation of half from the y-axis. So it's a dilation of half horizontally. Okay, and the way we verify this is through here. So look at the brown section. So we know that the new x value is going to be half of the old x value. So we want to sub in the new value for the old x value, so we have to do in terms of the old x value. So we get x equals 2 times x dash. So now we can sub in an expression in terms of x dash for the old x value. So we get f of x becomes f of 2x dash. Same thing with the translation. So yeah, the new x value is 2 less than the old one. We want it in terms of the old x value, so we can sub in the new x expression. And we get x equals x dash plus 2. So first we do the dilation. We always do dilations first before transformations, which is here. And then we're transforming just the x. It always has to be in terms of just the x. So we have to do the brackets, put a bracket left of the x in between the 2 and the x. And then we add 2, and then we close the bracket. And that's what it looks like. Just for interest, I'll show you what it would look like if we did translation first. Right. So if we did translation first, we'd get this, right? Which is not what you want. Okay? So that's basically why we always do dilation first. Okay, so now we know it's all the x values are being halved basically, and all the x values are being moved 2 to the left. So now that we know that, we can imagine it happening here. Also, it's really important to know that dilations also dilate your bounds. So, for example, here if we dilate 2 from the y-axis, all the x values will be multiplied by 2, so you go from an interval of 0, 2 to 0, 4, an interval of 1, 3 to 2, 6. Okay, so this is what the dilation would look like in the first step. So it go from 4 to 8 to 2 to 4. The area would be halved. The translation moves the interval from 2 to 4 to 0 to 2. But the translation does not change the area. Okay, so all that's happening to actually change the area, which is what they want, is a dilation that's halving the area. So the area is just halved. So it's equal to 5 on 2, which is E. Question 10, okay? So basically this is kind of like a pick it up as you go along question. So we have an equation. It's saying we want n. We want n in terms. So we want what values are n so that x is positive. So we want everything in terms of n basically. So we have to solve this in terms of n. You can do that in your calculator like this, or probably easier just by hand, where you get log base 2 of n plus 1 equals x. Bring the 2 to the other side. You get 2 to the power of x, then bring the 1 over, so you get n equals 2 to the power of x minus 1. Okay? So, now that we know n equals 2 to the power of x minus 1, we can see that in the answer there is an expression, there's a k expression of n equals 2 to the power of k minus 1, which is the exact same as the x expression. And I've shown over here that that pretty much shows that x equals k. Okay, so x is equal to k. if we use this as our answer, like going off instinct, okay, since they're saying we should use it. So this, if we use that, if we take that as an answer, then we get x equals k. And then because k is an element of z plus, so k is an element of the integers, positive integers, and the answer wants x as a positive integer, that's saying k is equal to x, k is a positive integer, x must be a positive integer, and that's exactly what we wanted from the start. So that means n, this is our correct answer, because this has already given us everything we wanted to. And if we want to, we can proof by substitution afterwards. So we can plug in n equals 2 to the power of x minus 1 instead of n into the original equation. We come down to x equals k again. So yeah, that we know that answer is right. The answer is B. All right, question 11. So we get a normally distributed variable x has a mean of 250. We know that z is the standard normal variable, so it has a mean of 0 and a standard deviation of 1. Okay. So basically what we want to do is we want to get, it's saying the probability of x, okay, it's saying that probability is equal to that probability. So you want them so that the inequality signs are facing the same way. So we rearrange 1 minus probability of z is greater than 1.5 to equal probability z is less than 1.5. Okay, and then that is equal to probability that x is less than 259. Okay, so that's basically saying since they're equal, it's basically saying this. So for this distribution, let's say this is z equals 1.5, x equals 259. The probability that it's less than that as either z values or x values for both is going to be equal to is going to be, okay, yeah, so they're both going to have the same area less than that. So past this point, the probabilities are both going to be the same, is basically what it's saying. So now we want them in terms of the same variables. So z is a standard normal variable, so must be expressed in terms of standardized values. So this value, 259, in terms of x can be standardized so that it's also in terms of z. The standardized z value of 259 is equal to 259 minus 250 over the standard deviation. And then here's just the general formula where we got that from. Okay, so since we know that the standardized value of this equals that, we just set them equal to each other, and then we solve for the standard deviation. So we get this equals that, and then we get standard deviation equals 9 divided by 1.5, which is equal to 6. And then once you get to this point, I would just chuck it into your calculator, and then you should get the standard deviation equals 6. All right, question 12. You guys can pause and read. I won't explain it, but you guys can pause and read this if you want. This is basically saying that sine and cos are the same graph, except they are horizontal translations of each other. They're the same thing, but translated horizontally for each other. And you can see that especially right here, okay? So for the standard graph, if you translate sine by pi on 2 in either direction, it'll be equal to cos. Sorry, if you translate by pi on 2, it'll be equal to cos. Okay? And the reason I say this is because people on this question, they'll immediately want to find what this height is, x, what the amplitude is. And then they know that this is the angle that the clock's moving around in, theta. They think this is theta, so then they go, oh, sine of theta is equal to x on 10, right? But we shouldn't actually be using sine, because as the question says, at 12 noon, right, which is the starting point, so t equals 0, we're already at a maximum height. Okay, so we're measuring everything in terms of height. So our function, which we want our function to be height, is already at a maximum at t equals 0. So you can see that here, especially, that's basically what's happening. It's starting at a maximum, it's going to a minimum, going back up. That's what a cos graph looks like. If it started in the center, so if it started here, then it'd look more like a sine graph. Okay? So we know it's a cos graph, even though a lot of people would be tricked into thinking it's a sine graph. So now that we know that, we have this general form. It's not x equals 10 sine t, because we know it's nt, because its period is, the period of a sine, normal sine graph is 2 pi. So this n dilates it, so we have the period we want. And the period for a 60-minute clock for the minute hand is obviously 60. So we know the period is equal to 60. We know the period is also equal to 2 pi on n. Okay, so we solve 60 equals 2 pi on n, and then we get n equals pi on 30. So now we have h of t equals 10 cos pi t on 30. And then we know the center of the clock / center of the function is 15 centimeters above the base. So that's what our center is, our starting point. So you have to do h of t equals 15 plus 10. Okay, 10 cos pi t on 30. All right, and that's pretty much all there is to the question. So the biggest thing people should watch out for is that people would immediately think it's sine, because they would try to calculate what that x is. But remember, even if you're finding this using a sine side length ratio, it still could be cos, because it could be, you have to look at the starting point. And yeah, so it's E. Question 13. So, so what we should be doing with this question is doing things our own way before we try and look at the answers. So we know this is in the wrong form. We know the form this should be in is this. So that's what we do. And then we list out what just like we've done in previous questions, we list out what the dilations and stuff are. So we know the dilation is half from the y-axis and a translation of 2 in the negative x direction, just like in the previous question. And so what the answer should be, just based off what we did, it should be something that looks like this. But that is not an answer there. So a lot of people would freak out. But this doesn't mean you're wrong. It just means you need to find an equivalent form. So with the first question, you kind of just have to trial and error the different forms. Like you have to trial and error, okay, what if I applied that transformation, what would y equal to? So here, the brackets, right, mean that now translation happens first. So go through the steps, but do translation first. Okay. So if translation's happening first, we're doing y equals cos of x minus 4 first, and then we're dilating it. And remember, the dilation only applies to the x value. So we get y equals cos of 2x dash minus 4. And then we take out the common factor of 2. So we get y equals cos 2 times bracket x minus 2. And that is exactly what we had up here. So that was what the answer should have looked like. So we didn't write the steps properly. So the steps should have been x dash equals x minus 4 So we get x equals s dash plus 4. And then with the other step, it should be in x dash equals half x, x equals 2x dash. And then we do translation first. So we get the x dash plus 4, and then we get 2x dash. And then we factor out, and then we get the form we want, so we know the answer is A. All right, question 14. So we have a normally distributed variable x, and we know the mean of x is twice the standard deviation. Therefore, we can get rid of the mean and just use the standard deviation. Sorry, we can sub in 2 times standard deviation for the mean. And we know that probably x is greater than 5.2 equals 0.9. So you have to recognize that this is an inverse normal question. So what probability what it's equal to. So instead of doing it in terms of x, we're going to do it in terms of z, the standard normal variable. And then we have to find what the probability of the z is less than we find the probability that z is less than a certain standardized value. So this is a certain standardized value. We need to find what the probability of z is less than that, because then that gives you an area here, and the area is what you put inside of the calculator when you're calculating the inverse normal. And the area is always the area up until that point. So let's say this is your standardized value z, saying what's the probability that z is less than that value. So z is all of this. The probability gives you all this. Yeah, and then that's what you have to use the inverse normal in the calculator. And then when you use the inverse normal, you end up with this. And then, so the standardized value is equal to this. And then you solve for what your standard deviation is equal to. Question 15. All right, so first of all, we need a note before we start the question that you can only differentiate or integrate if the function is smooth and continuous. Here, the 2 lines that make up f can be integrated separately. So they can only be differentiated or integrated over an interval where the function is smooth. So here we have 2 intervals, and then if you just look at these intervals separately, individually, then you can actually differentiate and integrate them. So then we have to find the equation of what the lines are. So to find out what the equation of the lines are, we need to know what the gradient is and what the y-intercept is. Here they already give you the y-intercept for both lines, because they both come to a point at the y-intercept, and it's the y-intercept is negative a. Now what we have to do is find the slope. So the slope, we do the rise over the run. You do that for both lines, and then you should get these 2 equations here. Once you have those 2 equations, then you need to know how to find the average value of the function over an interval, and that is the area given by an integral over. So it's the area under the curve for that function, or the area given by an integral over the interval divided by the magnitude of the domain / interval. So for example, if we had this here as f of x, and it was from 0 to 2, then the average value of the function would be, so first you divide by the interval size, which here is 2, and then you integrate over the interval, and that's how you'd find the average value. And the reason we say magnitude is because, you can have negative values for the interval, and the magnitude here is 3, because the distance between -1 and 2 as x values is 3. So then you'd have like that. Okay, does that make sense? Awesome. All right, So also, when you have this and you find the average value of two, so you're integrating two functions separately because they are not continuous and smooth over the whole thing. This applies to everything. So make sure you have a bracket. Make sure the bracket's covering both integrations. And once the bracket's covering both integrations, put both integrations in. Make sure you have the right intervals for each integration, for each integrand. And yeah, and then you should A on 3 as your answer. Pretty simple once you know what to do. For this question, immediately you should see maximum area. Whenever you see maximum area or minimum area in maths, 99% of the time, you're going to be finding the derivative of a function and then setting it equal to 0 to find what the max is. So first here we have to create a function, and it's asking for area. So we're going to create a function that models the change in area, and then we're going to set the derivative of that function to equal to 0, and we're going to solve for the x value that gives that maximum area. So here you have to notice that the y value here gives you this length, and the x value here gives you the horizontal length. Okay, so we have m and 9 minus m squared as side lengths of a triangle. So now we use the area of a triangle, which is half height base times height. And then that is your formula for, so you put this, that's your formula for area. So now you put that in your calculator. And once you put it in your calculator, you solve the derivative is equal to 0. You get m equals plus or minus square root of 3. And then you know that m is between 0 and 3, so it has to be positive square root of 3. Right? Okay, now we have a function that solves for area when given an x value m. Now we know that the x value m, so the m value of root 3 gives you the maximum area. So now you put that m value into your area function, and then that should give you the maximum area, which is root 3 times root 3. So the answer is D. Question 17. All right, immediately here you have a graph, negative log, natural log of x plus 2. You have a tangent on the graph of f that has a vertical axis intercept. Okay, it has a vertical axis intercept at 0c, so it has a vertical axis intercept. So we're trying to find the maximum value. So what you should do first is just put that straight in your calculator to see what it looks like. And then if you want to, you can like sketch like a smaller version just on your paper. And then you want to draw a bunch of tangent lines like I've done here. And then you want to think about where those tangent lines are going through the y-axis, okay? So that's where your y-intercept will be. And you should notice that when you have your tangent originate, or like touch the f of x on the y, when you have it touch f of x on the y-axis itself, that's when you get the maximum intercept value, the maximum c value. And we know we know that's when x equals 0, so we solve f of 0, and we get negative log e of 2. And then it's as simple as that. So this one's just kind of visualizing graphically. All right, so for question 18, we have function h of x, it's equal to a over x plus b. And so first we should just sketch what we think f of 1 on x looks like. It looks like this. Okay, but now we know that it doesn't go to negative infinity. The x value doesn't go to negative infinity and positive infinity. The x value only goes to negative a and positive a. Sorry. Oh, the x value is only right. So the x value, the x values only go from negative a to a. And then now we've got to think about what do the y values look like, or what do the h of x values look like at these endpoints? Because these x endpoints, the x values of these endpoints will be important to find what the y values of the endpoints are. So we know where the x values of the endpoints are. Now we sub it into h of x. So we sub in h of a, which is equal to a on a plus b, which equals b plus 1. And then we go h of negative a, which equals b minus 1. Okay, so those are the y values of your endpoints. And now basically you know the y values of your endpoints. Now you know what the range is. The range, as I've shown over here, that is the range. So the range goes from negative infinity all the way up to b minus 1. And then it goes from b plus 1 all the way up to positive infinity. So that is your range. So the answer is D. Okay, question 19. So we have the graph of P. We know that P is a probability function where X is the number of sixes that are rolled. We know that W is the number of rolls that aren't sixes. And so we know X is the number of sixes out of 20 rolls. W is the number of rolls that aren't 6 out of 20 rolls. So we know that X equals 20 minus W, and we know W equals 20 minus X. Okay. So now we write out what the function for P of X is going to be equal to. So we know it's going to be 20 rolls. So we want to choose X amount of successes, X amount of times to the 6. And then we write that out. We do that for Q as well, Q in terms of W. And now I'm showing you how to do that here. And then since we want to look at how we can change, because the answers want to be in terms of P and W. You can see all of these answers are in terms of P or W. So we want to see how close we can make P of X and Q of W so we know how to get Q in terms of P, because that's what we want. We want Q in terms of P because the answers over here are in terms of P. So we rearrange Q so the 1/6 is here and the 5/6 is here so we can see it better. And then we end up with this. This is Q of W, and this is P of W. Now we can see the only differences between P and W and Q of W are the powers here, right? So the way we make these the same powers is by putting in 20 minus W. So for example, we go, how do we make 20 minus W equal to W? We get 2W equals 10. No, fuck, that's not what you do. Anyway, you want to change this. What can you do to put in? Wait, do you know what we should do instead? Okay, so now we know X is equal to 20 minus W, right? So now, right, we know that P of W is already pretty close to Q of W. But if we want to make them the same, all right, we're going to find P of 20 minus W. And that's still equal to X, right? 20 minus W is still equal to X. So the probability of success is going to be the probability that X is successful, which is 1/6. Because X is, the chance of rolling 6 is 1/6. So we do P of 20 minus W. And then, so whenever you see a W for this one, or an X for this one, you put a 20 minus W. And then you end up all right, then we end up with this. And to be able to complete this question, you need to know that here 20 choose 20 minus W is the same thing as 20 choose W. And you can prove that here. It's kind of like symmetry properties of combinations. So 4 choose 0 is equal to 4 choose 4. 4 choose 1 equals 4 choose 3. 4 choose 2 equals 4 choose 2. And the general form of it is A choose B equals A over A minus B. Sorry, A choose B is the same as A choose A minus B. So then this 20 choose 20 minus W becomes 20 choose W. Right? And then this 1/6 to the power of 20 minus W stays the same. And then this 5 to the 6th to the power of 20 minus 20 plus W, the 20s cancel, you get left with W. And so that is now in the exact same form. So we know that this is now equal to Q of W, and they wanted Q of W. So now we know P of 20 minus W gives us Q of W. So A is the correct answer. All right, so for question 20, right, what we need to realize straight away is that the function is cos AX, okay? And now it's saying that f of x, so cos AX is equal to cos AX where there's a translation left or right, okay? And it's being translated by a factor by h, and h is an integer. So that means we know the period of cos also has to be an integer, because if you're moving the graph horizontally by an integer, it means the period has to be an integer, because the period is like one wave of cos. So if you're moving it by a period and it's equal to the same thing, then it has to be an integer also. You know, the period must be an integer. And then down here, we can show since h can be any integer at all, that means the period has to be 1. Because that means, so say, this is a period of 1, this is a period of 2, this is a period of 3, this is a period, no, sorry, that's a period of 1, but then we're just going through the successions. So h can equal 1, h can equal 2, h can equal 3. And when this point gets translated to that point, right, the graph's still going to go on as it and be the exact same. However, if we have the period is equal to 2, okay, so now this is equal to 2, and then h equals 3, where h is still an integer, that means you're shifting this starting point to 3, which is here, and now your graph looks like this, and everything's off, okay? So that means the period has to be 1, not any integer. The period can't be any integer, it has to be 1, because then it works for any h value. Then it works for any h value, integer value. So we know the period is equal to 1. And now we have to rework the equation. So we know cos AX, or f of x has become f of x plus h. So now cos becomes cos of AX plus h. And we know that this value is the dilation factor, right? That's the dilation factor there. So we know the period equals 2 pi on n equals 2 pi on a, and we know that has to equal 1. And then you solve for a equals 2 pi. Okay. So now we have cos of 2 pi x. So now we know f of x equals cos of 2 pi x. And up here, they show you what g of x equal to. G of x equals log base 2 of f of x. So then we store g of x in our calculator. We can do one of two things. We can do the more mathematically sound way, or we can do the quicker way. I prefer the quicker way. The quicker way is you literally just type domain in your calculator, open the bracket, put g of x in terms of x. This is for the T-Inspire, by the way. And in terms of x, and then you'll get, this will come up on your calculator, and you just have to let n equal 1, And when you let n equal 1, you get this bound here. And then when you get up to that point, I recommend you just make 514 and 314 into decimals. And then you make all of these values into decimals, because then decimals are easier to see what's bigger than fractions. And then you just see which of these intervals lies in the domain, and you get B. And then for this first method, you find the domain using the range. It tells you up here, the range is -1, 0. So your y values, aka your g of x values, and your g of x is here, must be greater than or equal to -1 or less than or equal to 0. And you can't just put this straight in your calculator, it won't give you an answer. So you have to get rid of the log base 2. So you bring the 2 to the power of -1, so you get half, and you do 2 to the power of 0, which equals 1. And now you can put this in your calculator, solve for x. This is what will come up in your calculator. You have to let n equal 1, like before. And then you get x is greater than or equal to 5/6, or x is less than or equal to 7/6. And so the only option within the domain is B as well. So both of those give you B, it's just the different ways of doing it. I'd say this first option is what they intended you to do, because they gave you the range. All right, and then that's the end of the multiple choice section. I hope that helped. Honestly, I don't think the test was too bad, as long as you make sure you know how to do every question before you move on. That's really important. Otherwise, you'll have gaps in your knowledge. And since we're quite far away from the exam, you still have time to make sure you understand everything before you move on. You don't really need to start really timing yourself and making sure you're good under time pressure until later. Now you just need to make sure you solidify applying your knowledge of these topics to these types of questions, and these questions are perfect for that. So with this question, the tricky thing was realizing what value should h. You have to realize the period must be an integer, and it must be 1 specifically. That was really hard. You have to have a really good knowledge of translation and the fact that cos has a period. Cos is a periodic function. And then apart from that, that one wasn't too hard. This one, you kind of have to find it as you go. You kind of just have to start writing the functions, and then in your head thinking, how can I put q in terms of p, and then realizing the relationship between x and w, x equals 20 minus w. So then you can do p kind of in terms of q, because you're using w, even though 20 minus w is equal to x. And then from there, it's kind of hard to realize that 20 choose 20 minus w is equal to 20 choose w. And so that question was very difficult, I'd say. So that's it. Thanks for sticking with me if you stuck with me. And I hope you all go well in your exams, and you don't fail, and you get a great study score and a great ATAR. Alright.